Hello students, I am happy to welcome you for the fourth semester, year 21 and 22. So in the fourth semester, the first topic you have to study is coordination compounds. So you should know what are coordination compounds. So coordination compounds, to understand the coordination compounds, so just I will tell you about the salts or the compounds. So here in the case of inorganic chemistry, so one is a simple salt and the one is a there are three types of salts you can see. One is a simple salts, another one is a double salt, and next one is what? Complex one. So here simple salts are nothing but sodium chloride is an example for simple salts, which is formed by the combination or union of two ions, sodium ions and chloride ions, or acid radical, one acid radical and one basic radical is present in a simple salt. Whereas in a double salts, more salt is an example for double salts. So ferrous ammonium sulfate. So that is in the case of ferrous sulfate is a one salt and ammonium sulfate is another salt. When you mix the aqueous solutions of ferrous sulfate and ammonium sulfate, and on crystallization you are getting crystals of ferrous ammonium sulfate. So here what is the third category you can see is a complex one. It is neither simple nor double salts. Okay, it is a complex salt. What is a complex salt? It is not a immediately what you can say, it is not a simple. Next question is why it is called as a complex salt. Complex salt is nothing but it contains a complex ion, so therefore it is a complex. What is a complex ion? In the case of complex salt, so it is a very familiar compound, cuprammonium sulfate, CuNH3,4 SO4 as a complex salt or a complex compound. Then potassium ferrocyanide, K4Fe CN6, and potassium ferricyanide, that is K3Fe CN6. So these are all complex compounds or a coordination compound. Why they are complex compounds? They contain a complex ion. What is a complex ion? Which is not a simple ion like a sodium ions or a Cl minus ion. A complex ion is what? Only, so it is formed by the two or more simple ions. That is why the name is called as complex ion. And the second answer for the complex ion is, it is you cannot detect or analyze or find out the complex ions by simple semi-micro qualitative analysis. That is why the name is called as complex ion, FeCN6. Neither it answers Fe plus 2 ions nor Cn minus radical. Similarly, in the case of cuprammonium sulfate, it contains the complex ion CuNH3,4 plus 2. Therefore, if you do the semi-micro qualitative analysis, neither it answers the test for Cu plus 2 nor SO4 2 minus. So that is why it is called as a complex ion. So therefore we will begin with the coordination compounds or a complex salts. The coordination compounds are nothing but it contains there are two parts are present. One is a complex part and another one is a ionic part. So complex compound are nothing but it contains a complex part formed by a certain number of ions or neutral molecules and coordinated to a central metal ion. Therefore, coordination compounds are placed in the complex ions are placed in a coordination square. So therefore, it is a square bracket should be there while writing the coordination compound. Otherwise, it is a simple compound, not a coordination compound. Okay. If you hear the class in a classroom and if you hear the class in a outside or the ground, what is the difference? In the classroom you are sitting inside the four walls, whereas in the open space there is no walls are present. You can see how many sides are there. If there are 8 sides, more than 8 sides are there, you can visualize the more than 8 sides, right? If there are 4 sides, you can see the 4 sides. So therefore you can see as many as sides while the teacher is taking the class. But in the classroom there is no other possibility or alternate. Why? You are sitting, or you are forced to sit inside the, in between the four walls of your room, right? So the coordination compound is nothing but it is placed inside the coordination sphere. Okay, so therefore in the case of K4 FeCN6, the complex part is FeCN6 4 minus. So it is formed when 6 cyanide ions are coordinated to the Fe plus 2. Okay, what are the characteristics or the properties, or what is the nature of the coordination compounds? Coordination compounds are nothing but they retain their identity in the solid state as well as in the solution. So therefore, if you put the coordination compound to the solution, it will remain as a solid only, or it will maintain its identity as a coordination compound. If you take sodium chloride, only it will remain as a solid or NaCl in the solid state. When you put into water, you can't find that where sodium chloride is there, right? So it will be in the solution form. Some sodium ions are there and some Cl minus are there. That is why you are feeling saltish nature, right? Sodium salt solution. Okay, so therefore it is do not retain the identity in the water, whereas ionize in different way than simple salts from which they are formed. What it means or what it infers: K4 FeCN6 formed from KCN and FeCN2, which will be ionizing as. So here in the K4 FeCN6 ionizes as, it contains potassium ions and a complex ion, that is FeCN6 4 minus, potassium ferrocyanide ion. So next we will see what is a complex ion is. Complex ion is nothing but it's an electrically charged species formed when a central metal ion is surrounded by ions or neutral molecules through a coordinate bonds. So that is how it is called as a complex ion. How do you classify the complex compounds? Mainly the complex compounds are classified into two types based on the complex ion present. If a complex cation is present, it is called as a cationic complex. If a complex anion is present, it is an anionic complex. Therefore, there are two types of complex compounds. One is a cationic complex, another one is an anionic complex. I will repeat. The cationic complexes are those complexes which contains complex cation. Only what you have to do? You have to reverse the name of the complex. Therefore, that is how we will get the answer, right? Anionic complex are those which contains complex anions, right? So therefore complex anions are what? Negatively charged anion, whereas complex cations are what? Positively charged complex ions. And what is meant by neutral? It's a very rare neutral complex. Mainly there are two types, okay? Cationic complex and anionic complex. If there is a neutral complex, it contains a neutral complex ion. So here you can't say complex ion, right? So therefore this is a complex which contains a neutral complex, okay? Therefore it is a very rare, okay? Then what is the significance of the coordination sphere or the importance of coordination sphere? So it is this. If you write the square bracket, it is a part of the coordination compound containing the central metal ion and the ligands which are coordinated to the central metal ion. So here the ionic part is called as what? Ionization sphere, and the other sphere is called as what? Coordination sphere. So therefore in the coordination compounds there are two spheres are present. One is a coordination sphere and another one is a ionic sphere. So here cuproammonium ion is placed inside the coordination sphere, whereas sulfate is nothing but it is placed in the ionization sphere. So what is a coordination number? So coordination number is nothing but the number of coordinate bonds formed by the ligands with the central metal ion in a complex. So here if there are 4 ligands are present around the central metal ion, the coordination number is 4. If there are 6 ligands are present, the coordination number is 6. So here there is one mistake. It is not CONH3 thrice, okay? It is CONH3 6Cl3, okay, NH3 6 turn, so it is by mistake, I will correct it later, okay. Then what are ligands? So these are the ions or neutral molecules containing one or more donor atoms which form coordinate bonds with the central metal ion in a complex. So here in this case, Cn minus as a ligand, amine as a ligand, Cl minus as a ligand. Then we will see what is meant by a ligand and what are the types or the classes of ligands. So ligands are classed. What are the different classification or what are the classification of ligands? So here ligands are classified based on the number of coordinate bonds formed by them with the central metal ion of the atom. So ligands may be either it is a monodentate ligand or bidentate ligand or polydentate ligand, and one more class is there that is called as what? Ambidentate ligand. Okay. So therefore, what is meant by monodentate ligand? So here the mono means single or un, and dentation. Denting means what? Linking with a central metal ion. So therefore a ligand which coordinates the central metal ion through one donor atom is called as what? Monodentate ligand. So therefore example for monodentate ligand is a Cl minus, ammonia, NH3, water. These are all examples for monodentate ligand. So here these monodentate ligands are further divided into three types. One is negative monodentate ligands, other one is a neutral monodentate ligands, and the last one is positive monodentate ligands. So here, so these are the typical examples for this different types of monodentate ligands. So here Cn minus, NO2 minus is called as nitrito. We go through this, right? The Cn minus is thiocyanate. NO3 minus is called nitrito. CO3 2 minus is called as carbonato. Then NH3 is called as what? Amine. H2 is aqua. Water is called as, in the IUPAC system it is called as aqua. Then NH2 NH3 plus is hydrazinium. NO plus is nitrosonium, and NO2 plus is nitronium. These are positive monodentate ligands. So these are also very few in number. Okay. Then what are bidentate ligands? Bi means what? Two. Dentate means what? Through two donor atoms. So therefore all the in the chemistry you will get the answer there itself. By two, denting, joining by through two coordinate bonds joined to the central atom. Such ligands are called as what? Bidentate ligands. Example for that is oxalate 2. So that is, this oxalate is a ligand which is formed by the oxalic acid. What is the formula of oxalic acid? COOH. COOH is oxalate. If you remove the two protons from oxalic acid, you will get what? Oxalate 2. Oxalic acid derived ligand, that is oxalate 2. Then this one is ethane 1,2-diamine or ethylene diamine. Okay. So here you are getting what? Dimethyl. So it is a neutral bidentate ligand. Okay. Then another one is for the negative ligand as a dimethyl glyoxymato. It is abbreviated as DMG. Then what are polydentate? Poly means many, dentate means many number, right? A ligand which coordinates central ions more than two donor atoms we call as what? Polydentate. If more than two, if three is present, three donor atoms are present, that is a tridentate. If four donor atoms are present or four, then it is a tetradentate. If five donor atoms are present, it is a pentadentate. Okay. Then example for tridentate, a ligand which coordinates central metal ions to three donor atoms. So here is a ethylene triamine. You know ethylene. You know ethylene diamine. You know ethylene triamine. How to write this structure? Very simple. Write the formula for ethylene. CH2, CH2, CH2 double bond, CH2. Just remove double bond and substitute one NH2, NH2. Now it is a ethylene diamine. Then remove one more this nitrogen. So and you substitute this NH2, then it is a, what is that? Ethylene diethylene triamine. So this one is what? It's coordinated central metal through 4-diene. So then it is a triethylene tetramine. Similarly, pentadentate ligands. What is penta? 5. So therefore, it is a pentad. Ethylene diamine triacetate 2. Hexadentate. EDTA. Ethylene diamine tetraacetic acid. It's a very easy to write the structure. How to write the hexadentate ligand? You know ethylene formula. What is the ethylene formula? CH2 double bond CH2. Write ethylene diamine, remove the double bond and substitute CH2 NH2 CH2 NH2. Then how many nitrogen group, how many NH2 groups are present in ethylene diamine? 2 diamines, NH2 NH2. How many hydrogen atoms are present? 4 hydrogen. In NH2 there are 2 NH2 is present, therefore totally 4 hydrogen atoms are present in from NH2. Okay, so therefore if you replaced acetic acid, what is the formula acetic acid? CH3COH. You can't replace as it is or substitute CH3CO there. So therefore what you can do is CH2COO. So therefore EDTA, that is ethylene diamine triacetate structure. So next one is what? Chelates and chelating ligands. So chelate is nothing but what? When a bidentate ligand S, or polydentate ligands coordinates to the central metal ion through 2 or more donor atoms, a complex with ring structure is formed. So it is called as what? A chelate. A ligand forms a complex ligand. Okay. Example for this complex ligands is Cu. So that is a chelate which is formed from the EDTA with the copper. That is a chelate. Okay. And here this EDTA is called as what? Chelating ligand. Okay. So this is the structure of EDTA. How to write the structure of EDTA. And the last one is ambidentate ligands. So ligands which both acts as a monodentate as well as a bidentate are called as what? Ambidentate. At one point it's a double act. In the one stretch it is a monodentate, and in the another stretch or in the another scene it is a bidentate. What is the reason? There are 2 donor atoms are present, but at same times it cannot coordinate to the metal ion. That is why it is called as what? Ambidentate. So that is a double act. So here initially if only it is coordinating to the nitrogen atom, it is a monodentate. If it is coordinating through oxygen atom, it is a bidentate. So it contains both nitrogen and oxygen as a donor atom. That is why it is called as a bidentate. Thank you, students. We will see the next topics in the forthcoming classes.